Hello, my friends of Kateri Labs. Welcome to this tutorial. This is tutorial for wave barrier design with OpenFOAM and Salome. So what are we going to model this time is a wave barrier. So we are going to simulate a wave that is let's say interacting with a wave barrier, and let's see how this can be modeled with OpenFOAM. Okay, so what do we need? We need a Salome because you'll find in the description of this tutorial the a geometry in Salome that you are going to put in a geometry that you are going to import in Salome. So let's see, we open here, we go to, you will find this on the description of your project, the description of the video, sorry. So, no, let's create a new one because actually the geometry is another type. It's not a project. I mean, you will find just a geometry. Okay, we wait till Salome give us the geometry part. Okay, cool. So we are going file, import rep, and here we go up, and then you will find on the description this wave barrier intake, but wave barrier. Okay. And this is the wave barrier. I mean, which is the wave barrier, this and this. So we are going to simulate a wave that comes from this part and actually goes through, I mean, crashes with this wave barrier, and we see how its interaction and how the wave is going to be, how to say, how the wave is going to be uh, smoothed or like we are going to see the amortiguation of the wave due to the installation of here, because actually this will be a bay or like an area where you want to protect from the big waves here. Okay, so okay, in this part this is pretty simple. What we are going to do, because first of all we are going to save our project. So save file, save, and this will be wave barrier one. Then we create some groups. So here, groups, create group. Okay, so first of all, we create group on faces. And then I select all of them here. What else do I need? Main shape. All. Okay. Okay, great. So we go to main shape, we select here, but we do not want, for example, I don't want this, so I remove it from my selection. And as well, I do not want this one, so I remove it as well from my selection. So, sorry. So in the end, I'm just going to work with all of this. Okay, I do this again, so you can see. So we go new entity, groups, create group. On group, we go here, and then we select our, that will be this one, and they say select all. But actually, I do not want this because I want this face in another group, so I remove. And I do not want this, so I as well I remove. Okay. Once again, maybe I made a mistake. New entity group, edit group. Okay. New entity group, create group. Okay, select all. I do not want this, remove. And I do not want this, so I remove it. Okay, we say, and this will be located, this will be called concrete wall. apply, and then this will be atmosphere. Apply, and this will be inlet. Apply and close. So here we have the inlet because it's actually where the wave is coming. This is the atmosphere and this is the concrete wall. Okay, great. First of all, we have to look sometimes at the geometry because we have to see how many elements are we going to put on our model. So there is a option here. Which option is this one? There was an option here. Sorry to bother you. Okay, this one? No. I saw that this one. This is point deformation. So if we click to a point, so this will be, this is at 2 meters above sea level. Yep. And this is at -3. So in fact, there are 5 meters elevation on this model. And this in the y coordinate is 25, and this on the y coordinate is 87.5. Okay. So this is very important when we want to deal with the discretization, because we want to create a mesh that is fine enough to represent the wave. I mean, otherwise you will have a very coarse. You will have a very coarse. Mesh that cannot represent the wave geometry. So, okay. So what we are going to do? We go to here to mesh. We save. It's always important to save because otherwise you will lose all your. You will lose all your work. Okay. Cool. Then we go to mesh. Then we go to create mesh. Okay. We wait. And this will be the solid, and this will be here NetGen, and then with this one NetGen 3D parameters, and I want that my mesh will be 0.5, almost 0.5. Yeah, because actually I will require in this 5 meter to have 10 layers. No, I think it's too much. It will be 0.8, 0.7. Yeah, 0.8, 0.7. I mean, the finer your grid, you will represent better the wave. But as well, you will have a lot of elements, and maybe those elements are not the ones that you want. So that's why we create a cursor. Okay, so we say okay, and then we say apply and close. Okay, we have defined our mesh, but actually doesn't mean that we will run our mesh. So here we say compute, and with this we create our mesh. Okay, so first you define the mesh and then you compute your mesh. Okay, cool. It's not taking so long, so we are going to wait. As I have told you while we are waiting, I strongly recommend that you sign up for our YouTube channel. I mean, if what you are seeing is interesting for you, it will be very interesting for us, or like very kind for us, if you sign up and subscribe to our YouTube channel. Okay. And what else? We are from Hatari Labs. We are a blog dedicated to knowledge sharing in open source software for water resources and environment. Okay, so I strongly recommend that you visit our website. Which is our website? Our website is qatarilabs.com. Okay, okay, which is our website. This is our website, so you can go and you can see our later posts. We have a lot of tutorials in Modflow, OpenFOAM, QAS, and Python. So it will be very worth it if you take us a visit on our website, and as well you follow us by Twitter or Facebook. Okay, so here we have this kind of faces, and here we have this number of volumes. Yep. So we have 64,000 nodes and 300,000 tetraedron. That's okay. Cool. What else do we have to do? We have to see our mesh. Our mesh seems okay. Seems fine. Okay. Then we are going to add some groups. So we create some groups on faces, on mesh, on this mesh, and group on geometry. Which will be the geometry? For example, this will be concrete wall, and the group will be as well concrete wall. And then we have another group that will be atmosphere, and this will be atmosphere. And then the third group will be inlet, and this will be inlet. Okay. Close. Okay, so we have our group, and we have the inlet, the atmosphere, and the concrete wall. So you can see you have the inlet, the concrete wall, and the atmosphere. That's that's all that you want to work. That's all that you will work with this. Okay. So what else you are going to do? File, export, UMP file. File, export, UMP file. But first of all, you have to select the mesh. Otherwise, you can just export this just in. So file, export, UMP file. And this, okay, I think that maybe I just will create a new folder that will be V2. And here I will create another that will be Salome, but because this is actually what you will get on this tutorial. Okay, so this will be mesh one, and okay, so I save it. Okay, and then I will save the project as well here. There. Okay, that's great. So I have this. Okay, what else do I need to run my project? Okay, then we need some basic, we are going to run Interform, we are going to run it on turbulent conditions, and there is already a sample like let's say, a blueprint of the model that I will give you as well to run this case, yeah? This will be like a tutorial of the many tutorials that has OpenFOAM, but specific for this area. So we say wave barrier. Okay, I will take this, and I will paste, no, in V2. Okay, This is a little bit heavy because it's actually with the simulation. I guess with simulation. Okay. Okay, as well, this mesh, it won't be this mesh because actually it will be the mesh that we have created. Okay. Okay, great. Okay. Uh, okay. Yeah. Till now, I will create a zipped value of this one, of the V2. Yeah, because this will be actually what you will get on the description of this video. Ah, sorry. You will receive another thing as well. You will receive the bitrate, this one. These are the ones. Yes, eliminate this and then create. Okay, great. So, okay, so far from this, I can close my Salome, and then I can open my OpenFOAM for Windows. So here I go to Open for Windows. Yeah, it's a very nice software. Yeah, very specific. So CDD, because it is where I am working. LS, so say simulation OpenFOAM, tutorial, wave, barrier, V2, because this is actually where I'm working. Because if you go to your, it will be D, simulation OpenFOAM, wave barrier, V2. Okay, this is where I work. Okay, great. And once you are here, you go to CD wave barrier, cool, and then again you have to, on the description of here, you have to, on polymesh, you have to delete all of this. Okay, and then you have to please remember those steps because otherwise it will run to you. Okay, then you have to go alpha water as well, you have to delete it, and then you have to paste this. Okay, and it will be this. Okay, let's have a look of what we have on this. Okay, first of all, alpha water. What I say about alpha water says that you have the inlet is with water and everything else, this is 0 gradient, I mean that water cannot go out or go in, and the atmosphere, like water, can actually get out of your system. Okay, this is what this says. Okay, cool. We go to K, this is the dynamic viscosity, and the K and omega are related to the turbulent flow conditions. Okay, these are the turbulent flow conditions. Yeah? Okay, this is the nu of dynamic viscosity, I guess. I mean, please read the OpenFOAM for documentation. And it's zero. It's zero because we are in turbulent flow conditions, I guess. And this is the omega from the turbulent flow conditions. This is the pressure, and we see that the atmosphere has a special type and rest is zero. It's fixed flux, so it means that water cannot go out. And we have I mean the wave have on the extension of this area have a volumetric flow is modeled as a volumetric flow close or constant of 1,400 cubic meters per second. Okay, cool. Then we go to constant gravity, transport properties, turbulence properties, and on system we go to control dict. And on control dict you have our simulation will be from 0 to 60, but actually won't be from 0 to 60 because it will be from 0 to 12, but we are going to stop the simulation. And the interval will be every 1 second. Yeah. Let's say that for this case will be 0.5 because actually I want to see with better discretization which is the development of the wave. Okay. So far, safe. And set field dig, it actually gives you the it actually gives you that water is filled, that the volume here is at the beginning filled with water. Okay, it do not give you nothing else. So okay, once again, that's it. And then we go here and we say ls and say ideas UMV. Oops, sorry, maybe I have pressed. And UMV mesh 1. Okay, so it actually will read the mesh that we have created and will translate it to this project. It will translate to this project. Okay, then we go to set fields. And this will provide the first conditions. Okay. Okay, cool. Alpha water not found. This is interesting. Set fields dict. Cool. It says that on set fields dict, alpha water was not found. What does it mean, this? Ah, okay. This is very interesting. And this is related, yeah, it had happened to me once, and this is related to entirely to Windows. Why? Because if we see ls from 0, ls from 0, that is actually the 0 folder, we see that alpha water is still alphawater.org, and here I see just as alpha water. So I have to change the extension of alpha water. So how do you say, how is this made? So it's a alphawater.org at alpha water, but it's actually from 0. So I hope that you get in touch with a little bit of Unix, because otherwise, like, it really depends where you are, how these scripts can be run. Okay, so 0 alpha water to 0, because actually you cannot do this on Windows. You have to do it here because, and then, okay, cool. And then this will be 5 watt. Okay, and then I say set fields. Okay, then I say check mesh. Mesh, okay. And then I say paraform just to check the initial conditions of my model. So here is paraform. Here is the wave barrier. Cool. And then on the wave barrier, we are going to say alpha water. And this will be alpha water with the wave and the initial conditions where water is inside the, where water is at the elevation of 0. Okay, so it's just this, as you can see. Okay, so I close it. I say Control C here. Okay, put clear just to have. And then I'm not going to, I don't know if I can do this with OpenFOAM for Windows, but I'm not going to put my process on parallel, so I just will run on the simple app. But first of all, I have to do another small trick. The other small trick that you have to go to Polymesh, you have to go to Boundary, and then you have to change concrete wall from patch to wall. Okay, just save it, and then there you can run interform. Cool. And let's cross our fingers because, okay, cool, it's working. Okay, I will run it this, I have run that before, but I will run it for 12 seconds. Okay, so if I run it for 12 seconds, I think I have 12 seconds of simulation. I mean, not 12 seconds because it actually will take longer than that. We can for 12 seconds, we can see the development of the water intake, of the wave barrier. Yep. Okay, so that will be all for this in this video, and let's see the results on the coming video. Okay, so please thank you for following us and hope to see you in the next video. Okay, see you. Bye-bye. Bye.